Bismillahirrahmanirrahim. Welcome to the third part of the 14th lecture of Statistics and Probability Theory. We will continue with the topic negative binomial distribution. Example: 3 people toss a fair coin and the odd one pays for the coffee. If the coins all turn up the same, they are tossed again. Find the probability that fewer than 4 tosses are needed. So what they are saying that there are 3 people and they are tossing a coin. So as you know that if a coin is tossed one time, there will be 2 possible outcomes. And if 3 people toss a coin, so the total number of outcomes will be 8. And they are saying that odd one pays for the coffee. As you know, when you toss a coin, you will get 2 possible outcomes, head or tail. So 3 people are tossing a coin. The possibilities would be head, head, head. That is, all 3 of them get head on their coin. Or they can have head, tail, and head. Up to so on, you will have the 8 possible such outcomes. The last one would be tail, tail, and tail. All 3 people will get tail on their coins. So the odd one pays for the coffee, and if all the coins turn up the same, they are tossed again. So as you can see that this outcome and this outcome, all of 3 them have the same turn up. Either they will get head, head, head or tail, tail, tail. In this case, they will toss again. But in cases like this, head, tail, 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 head, tail, something like this, the odd one will pay for the coffee. In this case, the odd one is this. Remaining 2 have the same outcomes and this one have the different outcomes. So this person will pay for the coffee. Or let's suppose you have the outcome in this way, head, head, tail. So this person is the odd one and this person will pay for the coffee. So find the probability that fewer than 4 tosses are needed. Fewer than 4 tosses, it means less than 4 tosses, it will be decided that who will pay for the coffee. So here 3 coins are tossed, and if all coins does not turn up the same, we will consider it as success. So as we know that probability of success, by definition, number of favorable outcomes divided by total number of outcomes. And we all know that when we toss 3 coins, the total number of outcomes would be 8. What about the favorable outcomes? Favorable outcomes would be head, head, tail, head, tail, head, tail, head, head, tail, tail, head, and tail, head, tail, and head, tail, tail. The outcomes head, 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 and tail, tail, tail will not be considered here because as it is said in the statement that if the all 3 coins turns up same, the toss will be repeated again. So these 2 outcomes would not be the favorable outcomes. Remaining 6 outcomes would be the favorable outcomes in which we have the chances to get the success. So what would be the probability of success? It would be number of favorable outcomes divided by total number of outcomes, which is 6 by 8. Now, here we have considered k is equal to 1. As we all know that k is the number of successes, and in this particular case the success will be that the person is selected to pay for the coffee. And if this experiment is performed, there is only one time that the payment for the coffee would be done. So k would be equal to 1. So by the probability mass function of negative binomial distribution, which is probability x is equal to x minus 1 over x minus 1 c k minus 1 p raised to power k and q raised to power, as q is the probability of the failure, which is 1 minus p, it would be x minus k, where x is equal to k plus 1 up to so on. So as they are saying that find out the probability that in fewer than 4 tosses are needed, so it would be probability x less than 4, which is equal to probability x is equal to 1 plus probability x is equal to 2 plus probability x is equal to 3. We have to stop here because they are asking that in fewer than 4 tosses. And we started from probability x is equal to 1 because the limit of the x as it is equal to x is equal to k plus 1, and we know that k is equal to 1, so this would be equal to 1 as we are substituting 1 instead of k. 1 plus 1, 2 up to so on. So the starting point is 1. So by substituting the values in the probability mass function of negative binomial distribution, probability x is equal to 1, we will substitute x is equal to 1 here, k is equal to 1, p is equal to 6 by 8, automatically q will be equal to 2 by 8, which is 1 minus p, and in probability x is equal to 2, we will substitute 2 in the place of x. And for probability x is equal to 3, we will substitute 3 in place of x. By simplifying this, we will find out find out that probability of x less than 4 is 0.9844. Next example, the probability that a student pilot passes the written test for a private pilot's license is 0.7. Find the probability that a given student will pass the test, part number A, on the third try, and the part number B is before the fourth try. So what's happening here? There is a particular student pilot here who is going to attempt the written test to pass it for the sake of license, and the passing probability is 0.7. Find the probability that a given student will pass the test. So we are interested in the probability of passing the test. So as you can see from the statement that this statement is satisfying the properties of the negative binomial distribution. The very first property was that outcome of each experiment is classified into two categories, success and failure. So what will be the success here for us? The student will pass the test. This is the success. And if the student will not pass the test, it will be failure. So the first property is satisfying here. The next property is the number of trials are not fixed. So what they are asking that find the probability that a given student will pass the test on the third try. So you were asked that the particular student will pass the test on the third try or before the fourth trial. So these number of trials are not fixed here. Student will keep going to attempt the written test until he or she will get the license. So number of trials will not fixed here. Next property, the successive trials are independent. Each time the student will attempt the test is independent from the previous time in previous attempt or in the next attempt. So all the attempts are independent from each other. And the very last one is probability of success remains constant. Here the probability of success is to pass the test and which is 0.7 and it will remain constant in each particular attempt or trial. So this is the case of negative binomial distribution. Here we have to specify the k, which is the number of successes. What would be the k here? As you can see from the statement that the particular student have to pass the test. Once the student have passed the test, he or she will get the license and the experiment is over. So probability of success is 0.7 and k will be equal to 1. Because once the student will pass the test, the experiment will be over. He or she does not need to appear again in the test. So k will be equal to 1 in this particular case. Now, as we know p is equal to 0.7, then automatically q will be equal to 1 minus p, which is 0.3. By using negative binomial distribution probability mass function, we have to find the probability that the given student will pass the test on the third try. So it would be probability x is equal to 3. So as you know that the probability mass function of negative binomial distribution is x minus 1 k minus 1 p raised to power k and q raised to power x minus k, where x is equal to k and k plus 1 up to so on. So now here we have substituted x is equal to 3, k is equal to 1, p is equal to 0.7 and q is equal to 0.3, which has given us the probability 0.063, which is the probability that the student will pass the test on the third try. Now you have to find the probability that a given student will pass the test before the fourth try. So probability that the particular student will pass the test before the fourth try. So the student can pass the test on the third try or on the second try or on the first try. So this would be the case. Probability x will be less than 4, which is equal to probability x is equal to 3. plus probability x is equal to 2 plus probability x is equal to 1. By substituting the values in the probability mass function of negative binomial distribution, and by simplifying this you will get the probability 0.973, which means that this is the probability that student will pass the test before the fourth trial. Mean and variance of negative binomial distribution. Mean of negative binomial distribution is mu is equal to k over p, where p is probability of success and k is number of successes, whereas variance is equal to k into 1 minus p over p square. Geometric distribution. Geometric distribution is basically the special case of negative binomial distribution. Whenever you substitute k is equal to 1 in the case of negative binomial distribution, it becomes the geometric distribution. So this is the probability mass function of geometric distribution, in which we have p raised to power 1, q raised to power x minus 1, where x is equal to 1, 2, up to so on. And the mean of the geometric distribution is mu is equal to 1 over p, and variance is 1 minus p over p square. Some characteristics of the geometric setting. Each observation or trial has two categories, success or failure. This is same as we have in binomial, we have in hyper geometric distribution. We also have this property in negative binomial distribution, and this geometric distribution is the special case of the negative binomial distribution, so it also possesses the same property. The observations are all independent. The probability of success is same for each trial. We wish to find the number of trials needed to obtain the first success. This point is the basic difference between the negative binomial and geometric distribution. This first success means k is equal to 1. Whenever we get the first success in the experiment, we will immediately stop the experiment. For example, let's suppose we are tossing a coin. We say that we will keep on going to toss the coin until we get the head. So as we get the head, whether on the first trial or on the second, third, fourth, we will immediately stop the experiment. So this is the geometric distribution. What are the differences between the geometric and the binomial distribution? The most obvious difference is that the geometric distribution does not have a set of observations n. As we know that in binomial distribution, we have the property that experiment is repeated a fixed number of times. And in geometric distribution, we are saying that we wish to find the number of trials needed to obtain the first success. So this is the basic difference between the binomial and geometric distribution. The second most obvious difference is the question being asked. Binomial asks the probability for a certain number of successes, whereas geometric asks the probability of the first success. So this is the basic difference between the binomial and geometric distribution. All these three distributions, binomial distribution, negative binomial distribution, and geometric distribution, are coming from the independent Bernoulli trials. As you know that Bernoulli trial is the experiment which is performed and have two possible outcomes, success and failure. Experiment is repeated only a one time, and all successive trials are independent, and probability of success remains constant from trial to trial. So whenever this particular Bernoulli trials are repeated n times, it will become binomial, as we have discussed this earlier. For example, if a coin is tossed 20 times, what is the probability that head comes up exactly 14 times? So this type of example is the case of the binomial distribution. And as you know that in negative binomial distribution, we keep on repeating the experiment until we get the required successes. For example, if a coin is repeatedly tossed, what is the probability that the third time head appears occur on the ninth toss? So such type of examples are the case of negative binomial distribution. Whereas in geometric distribution, as you know that the experiment is repeated until we get the first success. So the example of this distribution is if a coin is repeatedly tossed, what is the probability that the first time head appears occur on the head eighth toss? So this is the basic difference between the binomial, negative binomial and geometric distribution.